All right, this video is going to show you how to calculate percent air, but also look at how to calculate density, which is going to be important for our next lab. So let's look at density first. So if we look at density first, density is simply taking the mass and dividing it by the volume. Now typically your units are going to be in grams and your volume is going to be either in milliliters or cubic centimeters. And that'll make sense in just a second. Let's say I'm going to take this block right here, and this block says pine on it right there. It's a pine block, and I want to figure out what the density of this is. One way to find the mass, or the easiest way to find the mass, would be to walk it over to the back of the room where the table is with all the electronic balances, hit on, tear, and set it right on there, and I'd be good to go. I know what the mass is. So that would be quite simple. And if I look up here, I can write that down. So I walk it back, I get the number, and I get 41.37 grams. So the question then is, how do I find the volume of this? So I can use some measurements to do that. And I'm not really worried about you measuring, because you can have a ruler in your drawer and you can measure it. It's the rounding that's difficult. But let's first look at this. So we got length times width times height, and that'll give us a nice volume to use. But let's take a look again at how we're going to round off and how we're going to have certain digits and uncertain digits. So I took a picture of my first measurement, and remember I'm looking at all these numbers right here, and this again is just going to be the length of the block. So if I'm looking at this number right here, I can see that it's definitely between 6 and 7 centimeters. All right, my question then is it between I know for sure it's between 6.7 and 6.8. So I know for sure it's 6.7 something. So if I'm going to write this down, I would write it down as my length being 6.7, whereas, let me make that 7 a little nicer. That 7 is my last certain digit. This is a certain digit because I can find it on the ruler. 7 is a certain digit because, again, I can find it on the ruler by seeing it right here. This is 0.5, 0.6, and 0.7. The question is going to come, the uncertain digit that I always need to add, and remember, I always add one uncertain digit, is where exactly is that number? So I would have to round it. And I'm thinking it's greater than 5, but not quite 0.9. So I'm going to go ahead and say this is 6.77, okay? So again, remember, when you're making your measurements, you want the number that you see on the ruler, which is the big number, and then the hash mark, which represents 6.7 and 6.8. So that's a certain digit. Again, this is a certain digit, and this number is an uncertain digit. So we want to add that to it. That's the one that we're uncertain, and we're basically rounding on that. So if I would continue doing this, all I would do then is keep measuring. So I say I grab this right here, and when I go ahead and measure not only the length like I just did, but the height and then the width. And let's say I get some numbers here. So let's say my width in this case would be 6.95, and my height, again, I can find these numbers on the ruler. This one is my uncertain digit, the one I can't see, and then 1.82. All right, so I have those three numbers, and each one of these is centimeters, centimeters, and centimeters. And if I multiply that all out, here's the thing. I'm taking numbers that have 1, 2, 3 sig figs, 1, 2, 3 sig figs, 1, 2, 3 sig figs. And out on my calculator, as I punch this in, I'm going to get something like 85 points. And then this is where I get a lot of numbers. 6, 3, 3, 7, 3. So how many sig figs should I round this to? Well, again, I look at 3, 3, and 3, so I'd underline 1, 2, 3. I would look at the neighbor, and that neighbor would tell this number to stay. So I get 85.6. And again, centimeters times centimeters times centimeters is centimeters cubed. All right? So now I have my volume. I also have my mass, so let's get back to it and put my mass, 41.37 grams, right here. again, type that into your calculator. And when I type that into my calculator, I'm going to get a number. And that number would be, I would have then 0.48. You can see a lot of numbers come up on the calculator. And that goes on for a while. But again, I'm going to go ahead and round this calculation, 41.37 divided by 85.6, to how many significant figures? So again, this one has 1, 2, 3, 4. This one has 1, 2, 3. I want to round it to the least significant, so I walk over here. Remember, 0 is a leading 0, so I ignore that, and then I go 1, 2, 3. Check out the neighbor right there. That neighbor tells me to stay, so I have 0.48 and then 3. It stops right there. My units are grams per cubic centimeter, which is exactly what I would expect it to be in this case. So that's how I would calculate density. Now this next part goes over percent air. So what I want to do is I want to look at what is percent air. In this case, how do I calculate basically how close was I in calculating the density of pine? So what I would want to do is take my experimental minus my accepted, and notice that there's brackets around that. That's absolute 0. So if you get a negative number, just go ahead and get rid of that. And then I would divide it by the accepted and multiply it by 100. So what do these terms mean exactly? Well, the experimental is basically how you would look at your value, the value that I got right here. And then the accepted value is usually something I can look up. So it's known. We know exactly what the density of pine is. And I know you're saying, well, if you knew it, then why are we doing it? Well, that's basically a good point, but we want to see how we can calculate this and see how close we are. Or maybe we don't know this is pine for sure. So let's do an example here. An example, again, let's say that a student determines the density of a substance to be 1.4. So that's with a student. That's the experimental. Okay, that's what we got. And then the accepted value, the one they looked up, is 1.36. So what you would do is you take this number minus this number, divide it by the accepted 1.36, and multiply it by 100. So what would you get? Well, you would get percent air of 2.94, which is amazing. That's a great percent air. It's a really good percent air, actually, because it's a very small number. That means you were just a little bit off. And that means you probably made some great, not only measurements, but you did some great calculations, and you had good rounding. All right? So the nice thing is when you open up this density and air analysis lab, you're going to see a bunch of information. And we just went over this right here. So, this is still important to look at. And we did leave it at milliliters here. And then I went further into this idea right here of percent air. Now, let's just kind of talk about now we use observed minus accepted. You could also say experimental. Experimental, observed, the same thing. So let's take let's take the number that we did before that was behind me, and let's just see if our number for pine was really that close. So something I should pay attention to is right here. Pine, let's write that down. The accepted value of pine, 0 points, and right here I have it, 434. And again, that's grams per cubic centimeter, or in milliliters. In this case, it's centimeters. So let's see how we did. Let's do a practice. So remember, my percent air equals what I got, my experimental or my observed, experimental observed, either one, minus what is accepted. I have to look up, and I have to do the absolute value of that divided by the accepted, and multiply that, all of that, times 100. Okay? So if I look, when I calculated that, remember it was 0.4 look at my notes here, 8.3. Okay, and I'll leave the units off just for now because we know what we're working with, and we'll talk about that later. So that was what I got from my calculation of measuring this, finding the volume, and taking it over to the back table. I'm then going to subtract what I know to be the accepted, which is right here. And then make sure I take the absolute value out. Now it doesn't matter in this case because this number is bigger than this number, so it will be positive. Divide it by that same number. Now notice when I do this, I'm going to subtract this number. So let's go ahead and let's do that on our calculator. So when I do that on my calculator, I'm going to type in 0.483 and I'm going to subtract 0.434. On my calculator, let me try that again. Forgot the decimal. I get a number that is 0.049. Now in this case, this is good because I have the tenths, hundredths, and thousandths spot, tenths, hundredths, and thousandths spot. So that's important to remember when you're doing this because you want to have the correct number of sig figs after the decimal. Then I'm going to go ahead, I'm going to divide it by 0.434. Now, nice thing again is, because of the sig figs here, let's think about what this number would be, okay? Because I'm dividing this number, I need to go based off of the sig figs that are available. Now, these are leading zeros, and leading zeros are never significant. Only trailing zeros are significant if they're behind a decimal. This is a leading zero, and it's not, so that means it's never. So I have 1, 2 sig figs here, and I have 1, 2, 3 sig figs right here. So that means my answer, whenever I find that, 0.49 divided by 0.434 is going to be, of course, don't forget, I have to multiply this by 100. I multiply that by 100, then I get 11.29%. Now remember, I need that to 2 sig figs. So I'm going to go that to 2 sig figs, underline 1, 2, look at the neighbor. That neighbor tells this one to stay, so my error is 11%, which isn't too bad. It's not as good as the one in the example, but it's still pretty good for this situation. So in this lab, you're going to see you're going to do this for several blocks, and you're going to use the accepteds, and you're going to measure the mass and the volume, and you're going to find the densities, okay? It's important to know, though, that when you round and when you calculate, you use the correct measuring rules that we learned about earlier in this module, and we also use the correct number of sig figs when we calculate. We multiply, divide, and we subtract, because there's a lot of that going on here. We're also going to do this with some metals. And you're going to see that you're going to use this with metals. You're going to get a box of metals that have these metals in them. And so here's a better picture of them here. You can see they're all different colors. If you mix them up, actually, on the very top of it, you can see there's a Cu right there, which shows you it's copper. So you're going to go through and you're going to use, you're going to find densities by finding the mass and the volume, calculating the densities. You're going to use the accepted values to calculate. And then here at the end, you're actually going to get some unknowns here. And in these little vials here, there's little pieces of metal. And it's hard to see them, but they're just little pieces of metal. And it says to take a dime size, which is different for everything, for every metal that requires, but it's the size of a dime, not very much. And you're going to do the same thing you did in method 2. And here's some more here. Can't really see them very well, but some copper, maybe. Or maybe it's aluminum, or maybe it's lead, or tin, or zinc. That's the thing. These three, whatever you think they are, you have to match it up with these up here, and you have to decide which one's which. And you'll actually have 2 days to do this. So hope it goes well. Let me know if you have any questions, or Mr. Dillman, of course, too, and have fun.